So what you're going to be doing is looking at square roots, but then also cube roots. That's what this is, the third root, and fourth root, and even fifth root if you look at the bottom. So they're very similarly related, but what you want to do is understand what we're doing here and just kind of tweak it a little bit for the threes. So you guys know that the square root of 36 is just 6. But another way of looking at that is saying what number to the second power equals whatever is inside of here. Right? 36. So that's what you're actually thinking when you do these problems. So that's how you get an answer of 6, and that's why 6 is the answer for this problem. Same thing here. What times itself 2 times equals 41 over 81, and you come up with, well, what times itself is 4, and you get 2. What times itself is 81, you get 9, so just 2 over 9. Okay. So that's the square root. This is what you've already known. You've learned this quite a while ago. And some are easier than others. Some you have memorized. Others maybe not, but you can always use, like, well, if there's a 4 in there, maybe the square root of 4 is related to it. So the square root of 4 is 2. So if you have 2 zeros, because you're multiplying by itself twice, so that would be 20 times 20. And you could always put this in a calculator to verify. And what we're doing today in Algebra 1, and actually this whole unit, there'll probably be mostly whole answers, integers. Once you get Algebra 2, you have all the decimals and the approximating. We'll do a little bit in the middle there, but most of it will be nice whole numbers. Okay, so here's what we're going to change. On all of these, we have an index, that's what this is right here, of how many times we need to multiply to get the part on the inside, which is called the radicand. And what we could do, they don't really write this on each one, but square root kind of leaves this off. There's an unwritten 2 in all these that stands for we need to multiply 2 times to get this number. We don't really write it there, but that's what it means. Okay. So what we're going to do below is just change this 2 index to a 3. So in other words, what times itself, like on number 5, what times itself 3 times equals 8. So that's called the cube root or the third root. So it's very similar to what you've done with square root, where you had to multiply 2 times to get a number. But now you just have to look for the index here, and it'll tell you, well, it might be not 2 times, but maybe 3 times or 4 times. And then you can answer it in the same way. 2 times 2 times 2 equals 8, therefore the cube root of 8 equals 2. Go ahead and try 6, 7, and 8. See if you can get those. Check this on the next few. See if you guys get some matching answers. And as you guys worked on this, you found out, yeah, -1 times -1 times -1 is -1. So this is kind of new how we can have a negative inside here. Because before, if there was like a square root and we said, what's the square root of -4? We said, well, you can't do that. You can't multiply a number by itself and get a negative number. So that was impossible. And you're looking at 2 to figure out what to do about that. But with cube roots, it's perfectly fine. Because you can multiply by -3 times and get a negative. So this is okay. We can have a negative inside the radical, and you can have a negative answer. Number 7, very similar to the one above. Well, what times itself 3 times is 1? Not just 1. What times itself 3 times is 125? You guys found out it's 5. And after a while, you kind of get used to these, kind of like multiplication tables. You learn, you just know them. Same thing here. You kind of get used to, okay, 125, 125. And for 4, it's like 4, 16, 64, 216. You just start memorizing the multiples, just like you did the times tables. And you guys found out that 10 times 10 times 10 is 12. Alright, so when it came down to fourth roots, you just adjust it ever so slightly. So 1 to the fourth power equals 2. And in the same way, you figure out. Yeah. So the fourth root of 16 is 2, because 2 times 2 times 2, 4 times is 16. And even 5 times. So what times, so 5 times is negative 32. Now you already know based upon that the answer has to be negative, right? And then after a little trial and error, you find out, yeah, negative 2 would be the answer. Negative 2 5 times. So we're really just getting used to this new concept, and then next week we're going to really put this together with a lot of other things. And when we get to the last one, is it 2 as well?
Yeah.
Top 2 as well, yeah. There we go. Good. Next. Let's take a look at the next ones. 13, 14, 15, 16. So the next thing is, how can we get these non-perfect squares or perfect cubes? How can we get a decimal that's really close, once again, without using a calculator at all? Okay. So what we can do is see, well, what numbers, perfect squares, is this actually close to? So the square root of 15 is very close to square root of 9 and 16. We know it's between those two, so we know this decimal would be 3 point something, right? Because it's between 9 and 16 square root, which is between 3 and 4. So we know this is going to be, we're going to use the approximate sign here because we're approximating. We're not going to get it equals. So we know it's 3 point something, just with that alone. We know the perfect square above and below. Now, how can we get the 10th place here? The 10th. Okay. So is the 15 closer to here or here? Yeah, it's really close to square root of 16, so that means it's going to be one of the high 3 point something, like 3.8, 3.9. So we don't know exactly. So if you said 3.9, that's correct. If you said 3.8, that's correct. That's what this symbol means right here. You're approximating. So it's not going to be equal, which is exact. It's going to be close to. But we know it's not going to be 3.1, 3.2. That's the idea. We know it's closer to one than the other. Okay, so practice on 14, see what you get. Square root is 79. Which is between which two? 8 and 9, which is square root of 64, and square root of 8. So we know this
because that was closest.
is 8 point something, right? That's 8 point something. And is 79 closer to 64 or to 81?
81.
Yeah, so very similarly, you can get the 10th place by how close it is to one or the other. Now, if it was like square root of, let's say, 72, that'd be like right in the middle. So you could say like 8.5. If it's square root of 65, you can say, oh, it's like 8.1. And we're really just going to the 10th place. Don't try to do the hundredths or anything more than that. Anything more, we deduct it. So we understand, just like on 1 through 4, how square roots work really well. Now let's apply that for cube roots. So it's going to be a little different. We're not going to be using 9, 16, 64, and 81 because those are all square roots. We have to use cube roots. And those numbers you're probably not as familiar with. Okay, so cube roots. So cube root of 1 is 1, obviously. What do you have to do for the cube root of what? Yeah, cube root of what equals 2? 8, right? Yeah, cube root of 8 is what equals 2. Cube root of what equals 3? 27. And what we're trying to do is look for between, where do we get up to 100? That's what we're looking for. So it's not going to be 2 point something, so that'd be between 8 and 27. The cube root of what equals 4? Yeah, so it's not going to be 3 point anything because it's below, or it's above 64. And then cube root of what gives you 5? 125. So there we go. We know that a cube root of 100 is definitely going to be approximately 4 point something. It's somewhere in here. And now you need to figure out, well, where is it? Is it closer to 64? Is it closer to 125? Is it in the middle? Kind of in the middle. Is it an exact middle? Is it an exact middle plus a little bit more, or minus a little less? Yeah, so the exact middle of 64 and 125 would be probably like 70, like 100, like 90 something. So this is a little bit bigger than halfway. So we can say about 4.6. And these are the numbers that you're not quite used to that you will get used to. Okay? Alright. Lastly, you could do the same thing with variables. Okay? So, such as what times what equals x squared? Yeah, just x. X times x is x squared. What times what equals 9y to the fourth? So it has to be times itself.
3y to the second.
Right? Yeah. And then 3y to the second. Right? That would give you 9y to the fourth. So we know the answer is 3y to the second. So we're just using having variables in here as well. What about number 20? What times itself is w to the 128? Remember, you add exponents when you multiply, right? So, what would the exponents have to be here? 5 by 2 I heard, so that's going to be 64. Yeah. Yeah. Square root of w to the 128th power is w to the 64th. So you can look at it as dividing by 2 instead of 28 over 2. Alright, please finish that up. Bring it back on Monday. Finish before you come to class. And we'll see you then. Have a good weekend.